Stop it.
In section, everybody stop talking now. In section 7.6, which is the last section of this chapter, we're dealing with two new things that we can learn, and it's simply looking at how to find missing pieces. And once again, it's based on creating similar triangles. The first theorem that we see in this section is the proportionality theorem. And in this theorem, there is something that has to be true for it to apply. And what needs to be true is that you have a line parallel to one side of the triangle. If that line is not parallel to that triangle, or that side of the triangle, then none of this is true.
This is triangle proportionality theorem?
Triangle proportionality theorem, which says in a triangle, if you have a line parallel to one side and intersecting the other two sides, so it's inside the triangle, not outside, then it divides those two sides proportionally. God bless you. The two sides that it's separating or going through, it's dividing them proportionally. Now, after you get this theorem down, we're going to have a picture so we can see exactly what we're talking about. Yeah, it always makes it easier.
Did you pick up assignment 16 yet?
No, she has not.
No, I have not.
Thanks for asking that.
Yeah, 'cause I had it out for some reason. I had it wrong.
Okay. If you look at this triangle, now I have not stated that these two triangles are isosceles triangles. They look like it, but that's simply because that's what my little board draws, is perfect little isosceles triangles. So, assuming that these are not isosceles, if it's isosceles, then these two legs are equal to each other. Okay? But we're going to assume it's not isosceles because it's not told to be isosceles anyway. Remember, unless it's specifically stated, we can never assume.
Never touch the pictures. There's no middle points.
Now, because the segment inside the triangle is parallel to the third side, according to the triangle proportionality theorem, then the length of A over the length of B is equal to the length of C on the other side over the length of D. No. They're proportional. The ratio of A over B is equal to the ratio of C over D. I should have said that better. Okay? Please draw the picture and write that down, and then we're going to look at the same picture, but we're going to actually put numbers and see how we use this. Y'all got it?
Si, senora.
Okay. Remember, unless it is indicated that the two sides right there, or those two segments, are parallel, this does not apply. We have to know that they're parallel. Now, since we know they're parallel, if we're looking for the value of x, how would we set up a proportion to get that?
9/6 equals 12 over x.
9 over 6
Can we do 6 over 9?
equals 12 over x. Yes, you can say 6 over 9 as long as you set that equal to x over 12.
Cool.
All right. Remember, every time you're setting up proportions, if you in your head say, instead of numbers, but like long over short equals long over short, you know, and make sure that you're putting the same things together, then your proportion is going to be okay. Now, how do we figure this out? This is old stuff. Cross multiply and divide. X has a value of 8.
8.
Okay?
Ooh.
Yeah, it's easy.
I like proportions.
Okay.
So
Now, if I were to take this top triangle here, right here,
Yeah.
and remove it, or pull it out, I still have, that wasn't supposed to happen. I still have a large triangle, okay? And then a smaller one. Now, if those two lines are parallel, then we know that this angle here is equal to this angle here, because corresponding angles are congruent if the lines are parallel. We know that this angle is equal to this angle. So in the small triangle compared to the large, are they similar? Yes. Through which theorem or postulate?
the angle.
Angle, similarity theorem. All right? So basically what we're dealing here is two similar triangles.
So where do you get the angle?
Now,
The corresponding angles. Because
corresponding angles. Parallel lines cut by a transversal, corresponding angles here are
Wait, wait,
congruent.
wait. Oh, if two angles are congruent, then the third angle, obviously.
This third angle is obviously congruent because you have to finish your 180. Plus, it's the same angle. They're sitting on top of each other. Okay?
So if
Now-
I have
What we see here is several different proportions that can be set up when these triangles are sitting on top of each other. We already said if these lines are parallel, we can say that A over B is equal to D over E. But now, knowing that we have similar triangles, I could say that the ratio of A over C is equal to the ratio of, what do you think?
D over N.
D over F. Very good. Because I have this top portion over the entire side set equal to the top portion over the entire side. I could also say that B over C is equal to
E over F.
E over F.
E.
Because the small portion, or the lower portion, over the entire side is set equal to the lower portion over the entire side. Okay? You just have to make sure you've got your ducks in a row. Cows over horses, cows over horses. Okay? Now, how do we do that? Knowing this information, remember I have to know that these two lines are parallel to each other. If that's true, we learned all kind of ratios that we can set up. Now we can do this one of two ways. And the easier way is this. If this whole side is 25 and the top portion is 13, don't we know the bottom?
Yes.
It's 12. So now that I know the bottom, how can I very simply set up a proportion to find x? Jacob.
13 over 12 equals 15 over X.
Top over bottom equals top over bottom. Very simply. And then we would cross multiply and divide. And we're going to get a decimal. And I'm not sure what it is. It's 13 point something. Okay? All right. Now another way that we could have done it, and it's a little bit harder, but I could have said 13, the top portion, over the entire length, or the entire side, is equal to the top portion
Over 50%.
over the entire side.
That's actually easier.
Okay?
It's great.
So when you multiply 13, you subtract.
Now, I'm looking for x. I still have top over whole equals top over whole, and it's still a proportion where I've got to cross, multiply, and divide. The only thing to remember is when you multiply 13 times this denominator, what do? You've got to distribute it. Okay, so now we're just back in algebra class. Okay?
So that's why they make us take algebra first.
That's why it's smart to take algebra 2 before you take geometry.
Because of like everywhere else. you take
algebra
geometry
two-
before algebra.
I know, and I don't know why.
Because algebra 2 is better.
Okay,
I
so
hate geometry. Yes.
triangle proportionality theorem has just given us more ways of finding size.